Hey, how's it going? I'm Alex Miller. We released core async flow today, which is an exciting new addition to core async that Rich worked on earlier this year. And I wanted to do a short video. This is not super polished. I haven't re- practiced this a lot or anything like that. I just thought it was better to get something out quickly that kind of gave an overview, than, make something perfect. So. I have a few things that I want to go through. The core async flow rationale is worth reading as sort of the overview of what this is all about. The idea of flow is really that we can give you some new tools that allow you to sort of to use the things that are already in core async to build long-running um, systems that use a lot of those tools. And it importantly allows you to have sort of a strict separation of your application logic, the sort of the little kernels inside of your processes, from everything else, all of the topology, execution, communication, lifecycle, monitoring, error handling, all of those things. So that's the basic idea. There's kind of three important nouns involved in core async flow. Each little thread of activity is called a process. That is effectively backed by a function, usually a pure function. And then those processes are connected uh, with channels. Um, and then all of those processes and their connections build a directed graph of these processes. Um, And so if we look at this picture down here, this kind of tries to describe for you the things that you do, the things on the top, and then below the lines, the things that Flow provides. So you provide some process logic, and that is basically each process is backed by a function. The function has several different arities that do different things, and I'll talk about those a little bit. Um, and then you connect those processes using or you define those processes using some configuration. So you give those processes names, you give them a description of what kind of arguments are used when they're configured. You define their imports and their outputs. You define how those imports and outputs are connected. And then Flow provides for you everything else. So it has basically an execution loop for each process. That execution loop handles wiring, it handles thread policy, it handles lifecycle, so you can pause and resume, start, pause, resume, and stop your processes or the overall flow. You can throw out of there, and that will be taken care of through an error reporting channel. There's a general monitoring report channel and other features which I won't go into. Um, so basically, Flow gives you all of the tools to connect together these individual pieces together. Um, the I will say there's also some API docs here. Um, these are pretty dense, but if you work through them, I think there's all the necessary information is in here. If you look at importantly, um, you'll use process to create processes, and you'll use create flow to create a flow of processes. Those are kind of important things. There's some life cycle things in here like um, process, resume, start, and stop. Some command utilities like ping, and then some helpers that help with creating processes and doing other things. Um, so if we look at process in particular, each process is essentially a function with four important arities. Describe is a self-description arity, so it should return a description of the arguments that this process takes. Init is a function arity that is called when the process is started, and that needs to take values for all of the arguments that were defined in describe. We have transition, which is called anytime there is a state transition. So your process, as it runs, every time it gets invoked, it gets passed a state object. The init arity returns the initial state. Every time you pause, resume, or stop it, the transition arity is called, passing the current state and the transition type that you're going into, and it returns an updated uh, state value. So that allows you to, safely pause external things or do things like that. And then the main arity is really transform, which says, given the current state of this process, an input port where a message showed up and the message, what should I do? And then you return it a vector of, or yeah, a vector of the new state and a map of output channel to output messages on that channel. So this gives you the opportunity to sort of respond to different kinds of inputs that are coming into you. That's kind of the big picture. When you create the flow, you're going to pass it a map which has procs in it, and each proc is going to have a name and arguments and optionally some channel options for what the channels can be set to, or how the channels are configured. And then it's got connections, which are a collection of connections from uh, process port, a process port to some process port. Um, and then there's some additional things you can do for workload type. I'm not going to get into all the details of all that stuff. In addition to Flow, we also released a project today called flow-monitor. Flow-monitor is a real-time monitoring tool for Flow. So once you create the flow, you can start a monitor, connect it to the flow, and it utilizes the ping functionality that's built into Flow to know what's happening. It also gives you control over the flow while it's running to pause it. You can see the channels in between the processes. You can see backflow happen. You can look at the error, the reporting log. You can look at errors that might be happening. You can inject values directly into these channels in the middle of the flow for testing. So it's got a lot of useful functionality. I expect that it will change rapidly as we respond to what people have been doing with it. Um, so flow monitor is also useful. And then I'm going to work with a specific example here. This is in my personal GitHub Pure Danger flow example. This is intentionally a very simple example. It's probably not particularly representative of what you will actually build, but it's here to show you how things are connected together and maybe give you some ideas. So generator and scheduler are both input procs, and they have an external thread that's actually pushing values into an input channel. I could have done that directly on aggregator and not had these processes, but I wanted to have multiple processes here. So I separated those out. This generator and scheduler are really not doing their actual transformations, are not doing anything. They're really just passing values through from stat and alarm. So, but you can imagine they're connected to some other thing that's making stuff, a Kafka channel or a socket or something like that. So generator is created for testing. It's going to create values between 0 and 12. Or it's gonna cause to be created values from 0 to 12 that are going to come in on the stat channel. Those values are going to pass through to the out channel, which is then connected to the aggregator. The scheduler, same thing. It's causing values to occur on a schedule that come in through the alarm channel, and then the out channel just gets like trues put onto it, Boolean values put onto it. Both of those things are connected into the aggregator, which is where the only real logic in this example is. The aggregator sort of has two jobs. Its first job is when it gets a stat, it's going to check to see if the value it got is too low or too high based on its minimum and maximum threshold values. So you'll notice that the aggregator is set to 1 and 10 as the thresholds. The generator is set to 0 and 12 as the generated values. So sometimes you'll get values that are too low or too high. When that happens, it's going to send a message on the alert channel. It's going to send a map that says something happened and this is bad. Um, and then when it gets pinged by the scheduler on the poke channel, it's going to gather up all the values that is collected. So as it gets new stat values, it collects them into this vals key, and it's going to take its current set of values and summarize them into a windowed average, and then log it on the standard reporting flow report channel. And I think the only thing I haven't talked about is the notifier, which is just is getting these alerts, and all it does right now is just prints them to the console. So it doesn't do anything interesting, but you can imagine that being connected to your cloud infrastructure in whatever way is appropriate. All right, so let's look at the code. Um, so I'm not going to go through all the code. I'm not going to go through almost any of the code, in fact, but but it's out there. You can look at it on your own. So the create flow is going to tie everything together. So I'm kind of starting at the top level. We're going to define all the procs. These are the four procs that I just showed you in the diagram. The arguments that I'm passing in as their sort of configuration. So the generator has its values, the aggregator has its thresholds, the scheduler has a timing thing in it, the notifier has a prefix that it'll put on the log message when it logs it to the console, things like that. They are bound to vars. So you could just pass a function here. You can pass anything that produces a function that is uh, the right thing. There's some other options for what you do with all that. Um, in addition to args, you can also pass channel options. So this is passing the input channel options, which is a sliding buffer of 3. So we don't want the alert channel to back up. If something goes haywire and we're all of a sudden producing thousands of alerts, we don't want to block the entire flow because of that. So we're using a sliding buffer here. So we're willing to drop alerts on the floor, and that's fine. And then things are connected by the generator is connected to the aggregator, the scheduler is connected to the aggregator is connected to the notifier. So that draws all the lines that we saw in that diagram. We want to run that, and I'm gonna load this up here. So this is a new fresh REPL. And so I've created the flow now. I'm going to start the flow. Nothing has happened at this point. When you start it, it actually starts in the paused state. And then so we can kick things off by actually resuming it. So I mentioned that if you get high values or low values, those are going to fall through to the notifier and get printed. So you can see that's happening over here. So there's a process out there doing that stuff. It'd be nice to see all this visually. So I'm going to use flow-monitor, call start server, pass it the flow. I get back a server object, which I can stop later if I want. You'll see it in line here printed, this URL that I should go to on my local machine. So I'm going to go to that and connect to the flow, and there we go. So that's our live flow. I'm going to make this a little smaller just so it fits on the screen. Um, so we've got uh, those four procs. They're connected by channels. You'll notice that I made a sliding buffer for this one down here, and you can see that in the printout. Its capacity and current size are in there as well. Um, and then you can see the state of each of these procs showing up here as well. And this is definitely an area ripe for lots more work. We're not doing anything other than just printing the state right now, but obviously these could easily be tables and graphs and all sorts of things. So future work. We're also seeing some counters in here. That's the number of times this process has run. It's it's sitting in a loop that's being controlled by flow. So you can see that they're happening at different rates, that things are flowing through. You can see that the state is changing here in the aggregator. So the generator is producing values that get put in here. Periodically, the scheduler fires and tells it to log its output to the output channel. We can go look at the output channel. This is the standard flow reporting channel. So you can see it's getting averages and counts for each window. I think it's generating uh, every every 3 seconds, it's asking for an update on the value that's being generated every 500 milliseconds. So there's approximately 6 in each one. Um, and I think so that's pretty much the whole operation of what's happening here with this flow. There are a few other view options you can get here. I'm not going to go through all that. You can play with those. You can do things like pause one of these. So you start to see back pressure happening here. The aggregator is passing alerts to the notifier, and the notifier is not open for business right now. So those are kind of backing up. Because it's a sliding buffer, that's fine. It's just going to throw things on the floor as it gets full, so there's no back pressure through here. You can experiment with changing this to be just a normal fixed buffer and see what happens with that. Um, we can then let it go again, so it clears itself out. Um, you can, because I haven't tried this, but you can pause this one, so it's no longer getting new values in here. So you'll see it's just empty here. It is still printing. I think in the log you get an empty message in that case. Goes on top. Oh yeah. So you're just getting count 0 messages here showing up. Um, so we could do that. So everything is working just fine there. We can use this to inject uh, a message into this particular channel, which is where the stat values are coming in, or actually multiple messages. So maybe we can throw a monkey wrench in the works here, and you'll see that an error was thrown. So this error is telling you lots of information. It's telling you that in the aggregator process, so you get its PID, the current state of that was this. So importantly, the valves were set up to whatever. The message value that came in was wrench. And then we got this exception that said keyword cannot be cast a number. So this is enough information that I can go back to the function that's running the aggregator process, um, and give it the current state and the input channel and the message. I can reproduce this message exactly back on my original code. Um, so we could even try to do that here. Let's go back here and say, so we're running the aggregator on this aggregator function. Oops. Let's go look at we'll go near the code. I think I already have some of this here. Yeah. So we're going to call the aggregator function, and the function for the transform arity is state input ID message, right? So it's getting a min 0, max 12, vals, whatever. Those were the input ID. It's coming in on stat, and the message I passed it was wrench. So I can reproduce that same message that I just had. I can reproduce it over in my IDE, because all this all this aggregator function is a pure function that says it gets values on the input channels and it sends values on the output channels. It's probably worth looking at this a little bit. So this transform arity, we just saw the state, the input, and message. So based on the input ID, we're either getting something on the left fork or the right fork of that process. The left fork is the stat one, and it says add the current stat I got into the values. When the message is too low, then send it a low alert. When it's too high, send it a high alert. Otherwise, I don't have any messages to send. I'm just going to keep it around until the poke channel says that I should do something. So what I'm going to return is the state, the new updated state, and the new messages, which I didn't send any, I might have sent an alert, I might have not sent an alert, so this could be nil. That's fine. When we get poked, then we say, I'm going to reset my state to nothing. Um, and I'm going to report um, either an empty val message or a average val message out to my uh, out to the standard flow report channel. So that's you didn't see that in the graph, but every process has a flow report channel coming out of it, as well as a flow error channel that's coming out of it. So that's all just fine. Um, Another interesting thing to think about is because these are defined by vars, I can redefine them while the code is running, right? So this printer, for example, let's see if we can see this in real time. So if we pop up the report channel, we can kind of eyeball that as we mess with this. We can go in here to the printer function, which is doing nothing other than uh, println. I guess we'll see it over here on the right, and say maybe we want a timestamp. So maybe we can say uh, or let's do date. So it'll look like something useful. So I can just redefine printer, and at that point I start to get um, timestamps over here in my printouts, because so this is like a running system that we can mess with while it's going. Um, what else did I want to say? So you can pause the whole flow. So this pauses every component. If we go back here and look, you'll see that now all of these are paused. You can resume the whole flow. You can also pause and resume individual things just from the API. That's all the flow monitor is doing. We saw inject. That was so this is how you inject a value in here directly into the middle of the system. Um, you can ping the process and you get back a whole bunch of data. That's actually this is actually how the flow monitor works. Is it's just looking at all this data and assembling it together, doing useful things with it. Um, and I think that's it that I wanted to show. Um, so yeah, that's a very quick overview of flow. So go check all these things out and um, build some stuff and give us your feedback. Thanks.